Good afternoon, class, and welcome back to the math videos. I hope you're watching this on Wednesday and sitting at home. Unfortunately, I have no weight in whether we have school or not, so unfortunately I can't make that call, but it's not looking good right now looking out my office window, but we'll see. But we are beginning chapter 7.1, solving linear systems by graphing. So here we go. So here are the steps to solving the linear systems by graphing. Okay, so more than likely, well, I know that you'll be given two equations. So with both of these equations, the first thing you want to check is that it's in y equals mx plus b. So if it's not in y equals mx plus b, we want to make sure that we get them there before we do anything. And then you're going to graph both equations in the same coordinate plane. So you guys remember what a coordinate plane is? You're going to graph both equations, equation 1 and equation 2. And remember, you're starting the graph at your B, which is the y-intercept. And then you're going to create your line using your M, your slope. Okay? The most important thing to do is make sure you pay attention to where those lines are. Okay? What direction they're going in. So then you're going to check the then you're going to estimate the coordinate of the point of intersection. So for example, let's say that I had y equals x plus 3 and y equals negative 2x minus 2. So the first one I would start at 3 here, and I know that I'd have that dot there, and my slope is 1 over 1. So I know I'd go up 1 over 1, and I'd have that dot there. So I know in my mind that this line, which is a solid line, is going to be going in this direction. This is just a rough thing. We'll see an example in a second. But the second one starts at negative 2, and it's a decreasing line, so I go up 2 over 1. I know that somewhere in quadrant 2, these two should cross each other. So when it says estimate the coordinate of the point, you should almost think about, maybe even this is prior to graphing them, thinking about where they will intersect each other. Having a great idea of whether it's going to be in quadrant 1, 2, 3, or 4. Okay, visually seeing the coordinate plane, seeing the direction of those lines. Okay, and then there's going to be a way to check that algebraically by substituting that ordered pair into each equation of the original system. Okay, linear system. So let's check it. Let's go over this. Here's the example. X plus y equals negative 2 and 2x minus 3y equals negative 9. So let's go over each of these by the steps. So step 1, get into y equals mx plus b. So subtract x over here. This is y equals negative x minus 2. Okay. Subtract 2x. I have negative 3y equals negative 2x minus 9. Divide by negative 3. I have y equals 2/3 x plus 3 now. Okay? So y equals 2/3 x plus 3. So here's my two slope-intercept form equations. Now in my mind I'm going to think about where they're going to intersect. I'm going to start at negative 2 here, and it's going to go this way. Okay? Sorry about that line. Then I'm going to start at 3, and that's a positive line. So I'm guessing again that this will be, let me delete this line, sorry, hopefully in quadrant 2. Okay, somewhere around quadrant 2. So let's really graph it now. So I go to negative 2 on my first one, so I'm graphing this one. So it's decreasing, up 1 over 1, down 1 over 1. Okay, so that's our first line. Our second line starts at 3 and goes down 2 over 3. So down 2 over 3. Down, up 2, I'm sorry, over 3. Okay. Now, if I kept going on this line, I could see that they're going to intersect each other at this point right here. That's my guess. That at -3, 1, they're going to intersect each other. So now, I'm going to check it algebraically. Plugging this back in. I know this is my x value and this is my y value. So plugging them back into the equation. So I have -3 plus 1. I have 2 times -3 minus 3 times 1. And I need these to equal -9. And I need this to equal -2. So -3 plus 1 is -2. So -2 equals -2. That checks out. And -2 times -3 is -6. 3 times 1 is 3. So -6 minus 3, which is -9, equals -9. So that checks out. So I know this ordered pair, -3, 1, is the solution to this linear system of equations. So let's try one more. 3x plus y equals 11. Subtract 3x. Y equals -3x plus 11. Subtract x. We get -2y equals -x plus 6. Divide by -2. So I get y equals 1/2 x minus 3. Okay, so those are my systems of equations in y equals mx plus b. So that is step 1. Step 2, I said maybe you want to estimate where you think these will cross. So I start at -3 and it's a positive line. So it's going to go in this direction. And I start at 11, which is way up here. I'm going to have to create that. And I go, it's negative. So it's going like this. So I know that we should be crossing in quadrant 1. I can delete that. There we go. So let's do this. -3. Up 1 over 2. 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 Okay. So start at 11. Let's say this is 8, 9, 10, and 11. This will be interesting, but we'll try to get there. So I start at positive 11. I go down 3. So 1, 2, and 3 over 1. Down 3. 1, 2, 3 over 1. Down 3. 1, 2, 3 over 1. Down 3. 1, 2, 3 over 1. So these lines, I was a little wrong on my estimate. These lines will actually intersect each other, hopefully, at 4, -1, which is in quadrant 4. So I was a little off on my lines, on my estimate, but I had an idea that it would be on the right side of the y-axis. So let's plug it in and check it. Go back to the original equations. You can plug them into either of these, but I would plug them back into the original just in case you made a little mistake on your y equals mx plus b. You would find out that your answer was a little wrong. So 3 times 4, I'm plugging the 4 in here. I'm plugging the -1 in here. So 3 times 4 is 12. 12 plus a -1 is 11. So that checks out on the first equation. And then 4, this is the second one now, 4 minus 2 times -1, which is 4 plus 2, which does equal 6. So that does check out. So we know that 4, -1 is the solution. Okay? So again, steps. Rewatch this if you maybe got a little confused or if I went a little too fast. Make sure you rewatch. But you'll be given a system of equations. First thing is to check if it's in y equals mx plus b, and if it's not, to get it into y equals mx plus b. Number 2 is to kind of imagine where these two lines would intersect each other. Okay. Third step is to graph it. Okay, graph them using their b and their m. Okay, and I know we're used to making only a couple points like we have here. Okay, but now you may need to make more points to see where that definite intersection point is. Okay, and then check it algebraically. This is the most important part. If this does not come out, if this does not equal each other, okay, you did something wrong within your math work. Okay, you made a little error. Okay, so go back and rewatch this if you need to. Here's your homework. Problem number 1. Problem number 2. Here is your system, okay, of equations. Okay, so I should see this on a graph tomorrow. I should see it in y equals mx plus b. I should see that both of these lines are in one coordinate plane and these two lines are in a different coordinate plane, but I should see where they intersect tomorrow with an ordered pair, and that you checked it algebraically. Alright, if you have any questions, let me know. I hope to be seeing you on Thursday, possibly. I will make sure that I sleep with my pajamas inside out to maybe get that snow day. So I hope you have a wonderful night, and take care. Bye.